Okay, so this is section 4 into the quadratics unit. This is going to be the toughest section. So what I'm going to do for this is I'm going to go through the basics and a few examples for this, and then on a separate video I'm going to show a whole bunch of extra practice problems if you just want to see more examples, because here you're going to get some ugly looking solutions and some graphs that are not so nice. So that's how this one's going to be broken up. So if you understand everything from the basics, great. Give the practice problems a try, and if it's not working, take a look at the extra solutions that I've done so you can at least see a little bit more practice with that. So we are going to graph quadratics. That's the whole point of this, and we're going to look at multiple things. We're going to graph it looking at the vertex form and then graphing those out. So let's try this one. We want to do this. We're going to try and complete the squares. So I'm going to do it pretty quick. I'm not going to explain the whole process. If you're struggling with this, you need to go back and watch the other videos. So I do this, factor out the negative because I've got that there, the negative. Anything in front of the x squared we need to get rid of. And then turning this into a perfect square, what that's going to end up giving me is this. And bringing the negative into here. So really what I'm doing is subtracting 1. So I need to add 1 over here. And this will give me my equation of negative x minus 1 squared plus 4. So there's my equation. Again, if that was too quick, you need to review your complete the squares. So looking at this, my vertex is going to be positive 1 and positive 4. We know because it's negative, I'm going to have a downwards facing parabola. So these are just some things you need to know. So if I plot this, 1, 1, 2, 3, 4, there is my original point. So I can go out 1, down 1, out 1, down 3, out 1, down 5. Same thing, other way, 1, 3, 5. Here is my parabola. So it's asking us to look at the roots. So looking at this, I've got 1, 2, so we've got 2 roots. Let's try the next one. So doing this one, again, we can complete the squares to get the vertex. So I split it up here. This will give us x squared plus 6x plus 9. Then on the other side, I'm going to subtract 9. So this gives me x plus 3 squared. And then there's going to be a plus 0. You don't have to write the plus 0. I'm writing that for the sake of getting my vertex. So the vertex would be minus 3. And notice if I don't have the plus 0 there, that just means my y value is going to be 0 for my vertex. So negative 1, 2, 3, 0. And this parabola is going to open upwards because it's a positive squared. So I go out 1, up 1, out 1, up 3. By now you should get that pattern of out 1, up 1, or out 1, up 5, so on and so forth. So here is my parabola. Notice how many roots do I have? How many times did I cross the x-axis? Here, there's just one root, or solution. And then let's try this last one. So we've got x squared plus 4x. Break it up. We get x squared plus 4x plus 4 plus 6 minus 4. Again, I half this and then squared it. That's how I got this. That's the shortcut. If you need to write out this whole thing on the side of I want to get x plus 2 squared and work through that, you can. I'm just doing this quickly since I've got a bunch to get to at the end. So this will give me x plus 2 all squared, and then plus 2. So my vertex in this case is going to be minus 2, 2. So plot that, minus 2, 2. And it's going to open upwards. 2, 3. So it looks like this. So how many times did I cross the x-axis in this one? 0. So there are 0 roots. So there are 3 different cases with this, with the number of roots that I can have for a quadratic. I could have 2, I could have 1, I could have 0. So if you were to solve for each of the following, or each of these ones, as in just using algebra and solving this. So if I got this one, let's set this equal to 0. So negative x squared plus 2x plus 3 equals 0, and solve it. So factor out a negative, I get x squared minus 2x minus 3 equals 0. I can factor this normally, get negative x minus 3, x plus 1 equals 0. So notice from this we'd get 2 solutions, because I've got 2 sets of brackets. If I look at the next one, x squared plus 6x plus 9 equals 0. Solve this, we get x plus 3 squared equals 0. And again, now there's only one solution, because it's the same thing. If we tried the other one, we want x squared plus 4x plus 6 equals 0. If you try and do this, there's no way that I can set this up into 2 brackets. There's no 2 numbers that add to 4 and multiply to 6. So this one doesn't work. So actually trying to solve this, you can get something like that. Okay. So that is basically what you need to know about quadratics. Now, most of the ones that I've given you already are pretty straightforward. However, there are going to be some ugly graphs out there, and these are going to be some of the ones that I'm going to show you here. So what you want to do, and these are the instructions you'll be given, is you're going to complete the square to find the vertex. So we need to get the vertex. Then it says solve or factor to find the intercepts. And for these are going to be your x-intercepts. And it's going to be both x and y. So you need to do both. Because here we got indicate the nature of the roots, note the y-intercept, and sketch it. And then don't worry so much about verifying with the calculator. You'll be good with this. So what do I need to do for each of these questions, breaking this all down? I need to complete the square. Then I'm going to need to get my x-intercepts. Then I need to figure out my y-intercept. And what is the nature of the roots or solution? So I'm just specifically pointing these out, these 4 things, because these are going to come in the test, and you'll need to be able to do these pretty quickly, because as you'll see with the questions, it's going to take a little bit. So I'm going to show you one of these. I think, what's on the next page? Just doing the exact same thing. So I'm going to show you one example of this. I'll stop the video there, and then I'm going to do a bunch of other examples on the next page, and that's going to be something separate. So let's get into this. First, complete the squares. You can do this. So we're going to cut this in half. And first thing I notice, I have something in front of the x squared. So let's factor that out first. So 3x squared plus 3x plus 4. Already you're going to see the problem with this, right? If I try and divide this by 2, I'm going to get a fraction. It's not going to be the nicest, but we're going to make it work. So in order to do this, what I'm going to get for my root or my perfect squares, I'll get x plus this divided by 2. So 3 over 2 squared. Let's multiply this out. So I'll get x squared plus 3x, because that's what the middle term is, plus, if I square this to get the last term, I'll get 9 over 4. Again, already this is getting to be a little bit crazy. Plug it back in here. So we've got 3x squared plus 3x plus 9 over 4. And I need to figure out what I did on this side of the equation so I can cancel it out on this side. So what I did is I got 9 over 4 times 3, so I'm multiplying these two things together to try and figure out what that is. So 3 times 9 gives you 27. 27 over 4, you can't simplify that. So I added 27 over 4. So here I need to subtract 27 over 4 to get this. So writing this out, 3 times x plus 3 over 2 squared. This, just plug in your calculator. Once you get to this point, I don't need you to show me how to add or subtract fractions. Just use your calculator. So this will give me minus 11 over 4. So this is what you're trying to graph. Do I expect you to plot this out perfectly? Definitely not. Okay? So from this, I can get my vertex. That's why I'm asking for these things up here, is so that you can graph this pretty consistently. So the vertex for this is minus 3 over 2 negative 11 over 4. So that is going to be my vertex. If at this point you don't like the fractions when you're plotting this, you can write it as a decimal, but I prefer this. I'm just going to say don't do decimals, just leave it as this. Once you try and plot it out, notice here with the graph, there's no grid, because I'm not looking for a precise, I'm not looking for preciseness like this, where you get exact numbers. It's just going to look like this. So we've done one of the things. We've completed this square. Next thing we need to do is we need to actually solve this. So don't worry about the graph over here. I'm going to solve this here. So in order to solve this, we've got our equation here, 3x plus 3 over 2 squared minus 11 over 4 equals 0. And we need to try and solve this. So 3x plus 3 over 2 all squared. We're going to add the fraction to the other side. So equals 11 over 4. Divide it by 3 to get rid of this. So x plus 3 over 2 squared equals 11 over 12. Then we take the positive and negative square root. So we get x plus 3 over 2 equals plus or minus square root of 11 over 12. And then subtract 3 over 2. So x equals negative 3 over 2 plus or minus the square root of 11 over 12. Now, technically, you need to try and get rid of this root on the bottom to make this a more precise answer. For the sake of time and this unit, and because in radicals you already had to do something like this, I'm going to say just leave it at this. Okay? Don't bother trying to rationalize that bottom. Your calculator will do that automatically. So this is great because I can tell if you just simply use your calculator to plug this in or if you solve it by hand, because you will not see the solution from your calculator. So you actually have to learn how to do this. So here is my my roots. Now these numbers are going to be really tricky for you to actually be able to figure out where they are in a graph. So you can put this in your calculator to figure out where they are. So we've got our x, these are our x-intercepts, one with the plus, one with the minus. I've got my vertex, we've got that already. What else do we need? We also need our y-intercept. The y-intercept, not the hardest thing in the world. This one's actually pretty easy. So to get my y-intercept, all I do, look at my graph, or my equation here. Because to get a y-intercept, you plug in x equals 0. So to get y-intercept, this is at the point when x equals 0. So plug 0 into this. Y equals 3 times 0 squared plus 9 times 0 plus 4, simply going to equal 4. So the y-intercept, not too bad. That's probably the easiest part you're going to have on this. So now when you're plotting this out, you're going to do this. So I've got my y-intercept is at 4. So I'm going to plot this point. Say this is at the point 0, 4. I'm going to plot out my vertex, which negative 3 over 2 and this is approximately somewhere down here. Again, I don't need it to be exact. Please don't, I'm not expecting it to be exact for this, just in the right quadrant. So this is at negative 3 over 2, negative 11 over 4. So I'm indicating the vertex in my graph. Then my two x-intercepts. So just plug this into your calculator. Negative 3 over 2 plus root this. Figure out what the number is and approximate it. But just knowing what my graph should look like, I'm going to have here and here a vertex. Or sorry, not a vertex, a y-intercept. X-intercept. Because my quadratic needs to look like this. So I also need to indicate what these 2 points are. So this one is, here's my x value. So yes, you're going to have to write that in there. So negative 3 over 2. And you need to note when is it plus and when is it minus. So you got to be careful with this. This one is plus root 11 over 12. Y equals 0. And my other point on this side is going to be negative 3 over 2 minus root 11 over 12 and 0. So that is the long process that you are going to need to do to solve this question. Oh, I forgot to put nature of roots. So the nature of this is just saying 2 roots. That's the easy part once you've done all this. So I've completed the square. Let me walk you through the process again. Complete the square. Then once you did that, that tells you the vertex. Then you're going to take the completed square, set it equal to 0, and solve for the x values. Yes, you're going to have fractions in there. Yes, you're going to have roots, but don't freak out. Okay, you can do something like this. You just completed a whole unit on this. So that gives you your x-intercepts. Once you've done that, figure out the y-intercept. A nice little break in the middle of it that's really easy to do. Now that you've got that, you've got 4 points. Y-intercept, 2 x-intercepts, and my vertex. Sometimes you'll have 0 roots, sometimes 1 root. I just had a minor freak out at this point, so I thought I had just lost the entire video that I did, and I would have had to reprint this and redo it. Thankfully, I don't know what happened. My phone just shut down. So, continuing with what I said, this you might have either 2 roots, 1 root, 0 roots. So you might only have 2 points to plot. You might have 3. You might have 4. It doesn't really matter. And then when you plot this out, it just needs to look in general like it should. So your vertex should be in the right quadrant, should be opening up, opening down. You need to know what that looks like. And make sure you label your points, and don't forget the arrows. So that's what you need to do for this. I'm going to stop the video there, and I will go through some of these examples in a separate video.